Each and every year at SolidWorks World, one of the things that goes on is one of the more exciting things. It's kind of CAD's version of the Roman gladiators, of people squaring off to test their talents and their merit. And that's our Model Mania contest that we have in the Partner Pavilion each and every year. To talk about this year's contest, please join me in welcoming Mark Schneider. Mark, come on up.
As Fielder mentioned, every year in the Partner Pavilion we hold a contest. It's a modeling contest. We ask you to sit down and make a part, and then we ask you to make some changes to the part and run some quick simulation on it. These are the past, this is our 14th year, by the way. These are the past 13 parts that we did. You can see the complexity isn't real great, but you got to remember, we only give you 20 minutes. So whoever gets it done fastest is the one who's going to be the winner. This year, this was our part, the one that we chose. That's the wrong text at the top, but that's the right part. This is Model Mania 2013. You can see the part just has a couple of big bosses on the side. So on the left, the drawing on the left is the one that is what we give you to model. So we sit down and model this part. Secondly, what we ask you to do is make a change to that. So you don't know what the changes are as they're coming. And then we ask you to make a change to that and then run simulation on that as well. So that's really that simple. So what do you get if you win? Well, you win some fabulous prizes that were given to us or provided for us by our sponsor, NVIDIA. So really high-end graphics cards that are optimized for SolidWorks. And this year, we're offering the Google Nexus 7 tablet with the Tegra chip in it as well. So those are really good prizes for this year. So without further ado, what we're going to do is we're going to bring our champions, our winners, up here on stage. So I'm going to call out the names of all of our winners, bring you up on stage, and I'll actually walk through one of the ways that you can go through and model this part and make the change and do the simulation. Start with our customers first. Third place winner, Richard Wan from NJ Engineering. Come on up, Richard. Second place winner is Tom Smith from CHL Systems. Come on up, Tom. And our first place winner with the fastest time of anyone was Sadakal Khalsa from Triaxial Design and Analysis. Come on up, Sadakal. Sadakal's time was 8 minutes, 45 seconds to do both the part, make the change, and the simulation. So really great time. Great job, guys. So for our resellers, by the way, we do separate resellers from customers. So our customers don't compete against our resellers and vice versa. So for our resellers, our third place winner is Michael Steves from Quest Integration. Crowd likes him. Second place winner, Sean Bentley from Desai Solutions. And our first place winner is Gordon Stewart from TMS CAD Center. So let's walk through how this part could be built. Obviously, everyone knows there's many ways to build the part, but that's the drawing that you're given when you sit down to go ahead and begin the modeling contest. So I'm going to walk through how this could be done. In my opinion, I think one of the strongest foundations of creating a good solid model is with a sketch. I think all these guys recognize that as well. So we'll draw out a couple circles on the screen. I'm just going to copy these. Use just Windows Select, Control-C, Control-V. Why did I do that? Well, because when I use fully defined sketch, it knows to set those circles equal to each other. Saves me a little step there. We'll go through and change some of the dimensional values for some of these items here to get it roughly in place. Next, we'll add some arcs. So we're going to put some sweeping arcs across here. Just use the three-point arc tool, draw out the geometry, and then we'll add some tangency to those as well. Speed through this. Again, some people like to separate out their sketches. I like to put a little bit more information in the sketch. Both are valid techniques. We'll set all those equal to each other, and we'll add a dimension to control the size there. Next, I'm going to actually add the offsets while I'm in the same sketch. Some people added ribs, some people shelled it out. Again, all valid techniques. We'll just offset that by 3 millimeters, And the reason I do this is because I'm a big fan of using contours. They're a very powerful tool inside of SolidWorks. Hope everybody takes advantage of them. As we extrude this out, go ahead and use some of those contours that I have in my existing sketch there. We'll drag this out 20 millimeters. So there's my first 3 bosses that I'm going to add. Next, we want to add some webbing to connect all of them together. We'll just use the same sketch that we had. All that information is packed in there. We can allow the sketch to solve itself in a very concise manner. Make that 3 millimeters thick. Again, using the same sketch again, drag out our ribs there. These are going to be 12 millimeters deep. That's the basis of the geometry. The last thing we have to do is filleting. I had a lot of complaints from people that said filleting is really hard. My only trick here is what I like to do first is I like to try to fillet a feature. In this case, I couldn't really do that. Then I go to faces. Then I use the edge selection. The other great technique for this one would have been to use the new edge selection pop-up that pops up when you're selecting edges. That's a very good technique for doing that as well. It's not necessary to add the colors to the fillets. I like to do it because it helps me visualize whether or not I've added all the fillets to the model or not. So that's it. Once you're done with this, what we do is we give you another drawing. Say, okay, you got your model done. Now you got to make some changes to that part. These are the changes here. So we ask you to make some changes and then run some simulation. If you look in the section view at the bottom on the left, you can see that some of the bosses are all shifted in relationship to each other, and we also shifted some of the webbing. So a little bit of a challenge, but it makes the part stronger. It makes it better for the simulation as well. We ask you also to run simulation, hold the larger cylindrical face, and then add a load to the cylindrical face on the left. So let's walk through how you'd approach this. Since we're moving the bosses around, we'll go back, way back into my design, and I need to move some of those around. I could use the offset capabilities in the extrude command, that's one way, or I could use the move body. Since I don't have move body on my toolbar all the time, I'm using the command, I'm using the help at the top to use the command search. Just go up there, command search for move. It gives me that feature right away. I'm able to move those 2 bodies back 4 and 8 millimeters respectively. Next, I'm going to remove from my webbing extrude one of the contours. Just take that out because that doesn't belong there anymore. And I'm going to need to add it back in. So here I'm going to use the offset capability in Sketch, choose the vertex to offset to, flip the side to extrude, and that'll be 3 millimeters. So again, there's the basis of the geometry. The last thing we need to do is deal with our fillets. When you make a radical geometry change like this, you can expect that your fillets are going to fail. So we'll walk through that, repick some faces. And we've actually added 2 additional edges. A lot of people missed some of these extra edges that were added there. Once you're done with that, there's your part. Everything's ready to go. Always take a little bit of time to study your part. Make sure that you got everything done, completed, and you didn't miss a fillet here or there. Last thing we got to do is run our simulation. You're going to use, we give the contestants the ability to use either Simulation Express or SolidWorks Simulation. I'm using SolidWorks Simulation here. That's my preference. We hold down the larger cylindrical face, add a load to the smaller cylindrical face on the left, make that 500 newtons down, and then we'll go ahead and run our simulation. With the fastest solvers in the industry, we've got a couple of seconds here, we're able to get our stress values, stress information. I like to use the animation. It lets me understand if my part is behaving as I expect it. In this case, it is. And then we'll just create a factor of safety plot so I can get the minimum factor of safety. Right around 3 for the number, if anyone's curious what the factor of safety was on the part. And that was the answer. What is the minimum factor of safety? So we graded all these guys on who had the most accurate parts then on time. You saw some of the top times that we had there. And again, let's give our winners one more round of applause. Come on up, guys. Good job, Richard. Prizes will be shipped, okay? I got your email address. Prizes will be shipped to you. Great job, guys. Thank you.
Mark, thanks again, buddy.
Thanks,
Great
Dylan.
job this year.